In the concave mirror, we are moving our object closer and closer to the mirror and trying to understand how we apply the mirror equation to all of these cases in the same sequence of classes. Now we have actually will put our object between C and F. Okay, so we started from beyond C, then we put our object at C, and now we will put our object between C and F and understand where the image would be formed. So this is the ray diagram, you can trace it. Okay, and this ray diagram is very simple. The image would be inverted, it would be beyond C, and then it would also be magnified. Okay, and it's a real image, you can actually project it on a screen. Okay, so this is, all of these things are clear with the ray diagram, but that is not our objective. We want to actually apply this is our objective, apply this equation, our mirror equation, in this case of concave mirror. Okay, and we want to see, okay, so this is very important that you draw where this is. In my animation it's not there, but you should always draw it. Okay, and we want to see where the image would be formed by using this equation. This is the ultimate objective, because ultimately we want to solve numericals. Okay, so now let us understand where this 1 by u would fall. Okay, so we know that u is between C and F, which means that u is greater than 2f. Okay, sorry, u is greater than f. Okay, because it is greater than f in this direction, our image distance, and it is less than 2f. Why? Because it is between C and F. That's what it means. That u is our image distance, our object distance is greater than focal length, and it is less than the radius of curvature. Now, of course, when I invert it, then I would need to change the signs. That is what it means. When I invert it, then I change the signs. Okay, this sign would also change, and this will become. Now look at this equation. Our 1 by v is equal to 1 by f minus 1 by u. Okay, I've just taken f on this side. Very simple manipulations I am doing. Now what I know about 1 by u, this 1 by u is less than 1 by f, but it is greater than 1 by 2f. So when this 1 by u is equal to 1 by f, my 1 by v will be equal to 0. When my 1 by u is equal to 1 by 2f, my 1 by v will of course be equal to 1 by 2f. So that means that my 1 by v lies between these two. So 1 by v is greater than 0 and it is less than 1 by 2f. Now I can again do the sign inversion thing that I did before. So what do I get from there? If I invert the sign, okay, let me change my pen color so that things are clear. So this sign would become greater, this will become then 2f, and this sign will also become greater because I am just inverting, I am taking reciprocal. So when I take reciprocals, I have to invert these signs. Okay, and this reciprocal of 0 is of course infinity. Okay, so what does that mean? It means that my image distance is less than infinity but greater than 2f. It is always greater than 2f. So as I move, if my image is between this C and F, my object is between this C and F, my image would always be formed greater than 2f. It would always be formed beyond C, after C only. That is always the case. Okay, that is what this equation is telling me. And as I am taking this closer and closer to F, this object closer and closer to F, my image is moving further and further away from C. If I take it to F itself, then my image is formed at infinity, and that is the case. Okay, when the object is placed at F itself, by definition my image would be formed at infinity, right? So all of those things we can just understand this equation, just understand this case a little bit, and we can get glean at all of those details here. But the most important thing here is that my image is formed always greater than 2f. It's always beyond C if the object lies between C and F. Okay, and that is something that we have to remember. Directly questions are asked on this, and practice numericals again and again. I am telling you, practice numericals. You will be able to apply these equations very easily. These numerical, these inversion techniques and reciprocals, less than, greater than, all of those things. As you practice the numericals, we have discussed on DoorstepTutor the solutions where we have given these techniques in more detail. Thank you.